Alright, your homework was in the practice book, started on page 65. This is on understanding functions, and this first page was your prerequisite on proportional relationships. You should have talked about those last year. We will come back to them as well later on this unit. Study the examples showing how to write equations for proportional relationships and then solve problems 1 through 8. The example says that Kata is making pizza dough. For every 4 cups of flour, she needs 2 cups of water. Represent this relationship using a table and an equation. They've already made the table. If she uses 2 cups of flour, she needs 1 cup of water. 3 cups of flour is 1.5 cups of water, and they've got this all filled out for you. Now, all of the ratios are equivalent. There are 4 over 2 or 2 over 1. They presented it to you as 4 over 2, which would have been here in your table. Okay, you can use an equation. The ratio of flour is 4 to 2 or 2 over 1. The constant of proportionality is 2 over 1 or 2. Now, this is probably a new term, and we're not going to talk too much about it now, but we will later. Constant of proportionality, just think of that as the ratio of what you're using in the problem, and then we'll come back to it later. Then they're showing you how to write the equation. The amount of flour, F, is equal to that constant of proportionality, 2. Remember, it was 4 over 2, which simplifies to 2. And then you multiply that by the amount of water. Number 1, what does the constant of proportionality represent in terms of the problem? It represents 2 cups of flour per cup of water. When you're trying to decide what it represents, the ratio itself was 4 over 2. That was 4 cups of flour and 2 cups of water. So you just write it out in words. That's 2 cups of flour for every 1 cup of water. And I did do that in reduced form. Number 2 says use the equation in the example to find the number of cups of water you need if you have 12 cups of flour. Now, the equation said that cups of flour was equal to 2 times the cups of water. When they tell you 12 cups of flour, we're going to take out the F and we're going to plug in 12. So 12 is equal to 2 times W. Now we're solving for W. I need rid of the 2. The opposite of multiplying by 2 is dividing. If I divide the right by 2, I have to divide the left by 2, which will give me W equals 6. Number 3 says for a different pizza dough recipe, the equation F is equal to 2.5 W represents the number of cups of flour, F, that you will need for W cups of water. What is the constant of proportionality, and explain what it means? Okay, the constant of proportionality would be that ratio that we're multiplying by W. So the constant of proportionality, they use a K for that, is 2.5. Now, what does it represent? Okay, it's 2.5 over 1. That's 2.5 flour per, I wrote that wrong up here, didn't I? Flour. Flour over water. So it represents 2.5 cups of flour per cup of water. Now, they've given you a vocabulary word here for the constant of proportionality. The unit rate in a proportional relationship. Okay, it's the number of something per 1 of whatever we're using, like I showed you here with flour over water. Number 4 says Basir buys 4 small drinks for $6. Write an equation to represent the cost C for D drinks. Now, the total cost will be equal to a constant of proportionality times the number of drinks we buy. Now, the constant of proportionality is the unit rate. So they are buying 4 drinks for $6. 4 drinks for $6. So we need to know how much it cost. I think I have that upside down. $6, sorry, for 4 drinks. We need to find a unit rate or a cost per drink so that we can multiply. So when we divide 6 by 4, we get 1.5. So we would plug in that constant of proportionality and get the cost, the total cost is equal to 1.5 or $1.50 times the number of drinks you buy. Number 5, a horse ran 800 meters in 40 seconds, 1,200 meters in 60 seconds, and 480 meters in 24 seconds. Is this a proportional relationship? If so, what is the constant of proportionality and what does it represent? Write an equation to represent the distance, d, in meters that the horse runs in t seconds. So we want distance is equal to the rate times the time, if there is an equation. Now they've given us 3 different pieces of data. We want to calculate a unit rate. We want a distance per second. So we want distance per second. Distance 800 in 40 seconds. A distance of 1,200 in 60 seconds. And a distance of 480 in 24 seconds. Now, if this is a proportional relationship, all 3 of these ratios will be the same. Okay? If they're not the same, then it's not proportional. If we divide 800 by 40, we're going to get 20. I'm going to double check just because my brain's not all there today. Divided by 40 is 20. And then 1,200 divided by 60 is 20. And then 480 divided by 24 is 20, or 20 over 1. That's 20 meters per second. Okay, 20 meters per second. Since all 3 of these ratios are the same, then we know it is proportional. So yes, it is proportional. That was the first question. Okay, if so, what is the constant of proportionality? K equals 20, or 20 over 1. What does it represent? 20 meters per second. Okay, that's going to be the rate that the horse is running. And then the next one, so we've done those 3. Write an equation. The distance the horse runs is equal to its rate, 20 meters per second, times the time that it runs. Now there was 1, 2, 3, 4, 5 different questions in there. And we have answers to all of those. Got our yes. We got the constant. We got what it represents. And we got the equation. There's only 4 parts, and we answered them all. Number 6. The equation C is equal to 6.4 W represents the cost, C, for W pounds of walnuts. Does a value of 2.5 for W make sense in this situation? Cost is equal to 6.4 times W. Well, if W represents pounds and 6.4 is the amount per pound, would that give us the cost? Yes, it would. Okay, $6.40 is a logical price for those. Let's see. So yes, it makes sense if walnuts cost $6.40 per pound. Because if you want to know a total cost, you multiply the price times the number of items you buy, and you have a total cost. Lena and Michelle studied the data in the table. They each wrote an equation to represent the relationship between the number of miles and the number of hours ridden by a cyclist. Lena's equation says that her total miles is equal to 9 times the number of hours. So her distance is equal to her rate times her time. Michelle's equation says that the number of hours is equal to 1/9 times the number of miles that she rides. She's reversing it, but she is also changing the formula of her equation. Instead of it being 9 times the hours, it's 1/9 times the number of miles. The teacher said that both equations were correct. Explain why. Because the equations, these are equivalent equations written in different forms. They are the same equation. They're just solved for different variables. If we had taken m is equal to 9h and we had solved for h instead, we would divide by 9, which would have given us h is equal to 1/9 m. You see how it's the same equation? They just rewrote it to solve for a different variable. Number 8, Zach's car travels 21 miles on 1 gallon of gas. Okay, that's your constant of proportionality, 21 miles per 1 gallon. Write an equation to represent the relationship between the gas the car uses and the distance he travels. So his distance is going to equal to how many miles he travels per gallon times the number of gallons. Distance is equal to 21 miles per gallon times the number of gallons. Then solve the equation to see how far he travels if he uses 16 gallons of gas. So his distance would be equal to 21 times 16, and he traveled a total of 336 miles. 336 miles.